Hey guys, welcome back. I know you missed me last week. I didn't have any videos. I hope you got a good grade on the exam, and let's keep on going. We have half of a semester to go through, so very excited about this. Let's keep going. So now we're getting into analyze phase, right? So we did define, we did measure. We're gonna get into analyze. You're gonna see how bunch of cool tools we're gonna look at. Okay, so here's a little roadmap of our analyze. We're gonna analyze the process, identify potential root causes. We're gonna look at data, and we're gonna look a little bit more about data to understand the root causes, right? So what is analyze all about, right? So analyze is here it is. It's all about understanding the critical axis, right? So think that as a funnel of possibilities, right? So we start, you define the problem, and then the problem is you define your y variable, and then on measure you understand the process from beginning to the end, and a lot of details of the process, right? And understand the performance, understand what people are doing, what software they're using, what are the steps, and all that. And then a lot of things come to your mind of, oh, these things can impact on that y variable. What is the analyze phase about? Is funnel all those 100 different axes that x variables that you think about into, okay, what are the important few that are impacting most into that y variable? So that's the funnel process, because you get from 100 different hypotheses of things that might impact, and you qualitative or quantitative test and understand and analyze and have and use these tools to have a more data-driven decision. Say, oh, we tested and this is what the data gave us as an answer, right? So you're testing some hypothesis of the relationship between x and y, how x impacts in y. That's what we're going to do in analyze. So it's a key part, is maybe the largest part of the DMAIC process. It's the most important one, because if we get this wrong, we're going to fix a wrong problem. You can have great solutions, but if the causes are not the ones, the real ones, it's not going to impact your y variable. Okay. So before, I think this slide is about the Minitab. We'd already talked about Minitab. So this is when we're going to use a little bit more of Minitab, especially on the data part. So all the hypothesis testings and regression and all that fun stuff, we're going to use Excel, but also we're going to use Minitab as well, right? So get ready to use a little bit more Minitab as you go. Okay. Also, something I didn't tell you guys, right? As you can see, I'm in my sunroom, and why is that happening? Yes, because I was kicked out of my office. You guys know exactly how my life works. So let's take a look at this, right? What is the problem here? So think first. You know what the problem is, right? The water is dripping here, right? So we have water leakage here, right? And we can say that is the problem. But the problem has a little more things, right? So what is the water leakage, right? The water leakage is actually the symptom, not the problem itself, right? So let's say turning, the water, and it still runs a little bit. That is not the problem, right? Because the problem has different things. One thing is the symptom. The symptom is the water dripping, right? The cause of that, so the cause of the problem, could be different things, like mineral deposits, the warm O-ring, some damaged parts, some corrosion is happening. All these are potential X variables, okay? Or, sorry, they're X variables, they're potential root causes of the problem. Right? So all these different things can happen, or maybe I didn't turn, enough, right, to actually a little bit more. So I have a list of all these X variables, and then on analyze, what I have to do is I have to investigate what are all those X variables, which one is actually the one that impacts Y. And our Y variable here could be the water bill being too high, the water consumption. So I'm looking at the water consumption. and say, oh, this is too high. And then I go see, oh, where's that coming from? Oh, it's coming from the dripping faucet here. And then do some root cause analysis and say, oh, that's because I open it and see, oh, the O-ring is warm out, and then I need to change the O-ring. So that is the problem solving kind of step by step, right? And we need to understand that what is the problem? It's a vague question, right? Because we have elements in a problem. Okay, so we have the Y variable, which is the performance metric that's been impacted. We have the symptoms, which is the water dripping. We have the potential causes, which are all the 5 causes. And we have the root cause, which is, oh, that one that actually impacted on Y. Let's say it's kind of an investigation root cause analysis. I think that's why I like it so much. It's kind of, you're a detective, right? You have, 10 different suspects, and you're investigating each one of them to see who is the one that committed the murder or the burglary or whatever you want to call it, the crime. And then you have to investigate and see, okay, what are the potential suspects? And go and find out on those suspects which one has the highest probability of being the one that actually caused the problem. And then you have, of course, the solution. So although, problem solving, it's simple, right? Oh, we solve problems all the time. But people solve problems wrongly all the time, right? So there's one very important aspect here that I want to talk to. Not many people know how to solve a problem. Let's say if I have a headache, right? What should you do? Whenever you have a headache in your life, what do you do? Well, headache, what is a headache? Is it a symptom? Is it the problem? Is it the performance metric? Is it the cause? It's the symptom, right? The headache is a symptom, and you have it because you did something, right? So maybe someone can say, oh, just take an aspirin, right? You have a headache, just take an aspirin. Well, depending on what the headache is about, right? Maybe you drank too much last night, or maybe you have some allergies and some sinus infection, and then you need an anti-allergic medication, right? For allergies, right? So it depends on what the cause is. The drug that you have to take is going to be different. So the action that you have to make is different, right? That's why it's so important to go to the root cause. And most people don't do that. Even in companies in the professional environment, they just jump to conclusions. And you can see that in everything in life. In politics, it's very fun to actually observe and try to understand how people don't go to root cause and just jump to conclusions. But in practical life, that's the same. So one thing you have to be very careful. Don't jump to conclusions. Analyze and investigate. Imagine that every cop investigation or murder investigation is like that. Oh, I think that guy, yeah, put him in jail. No, that's not it. You have to go through a thorough process, and you have to have proofs, and then you have to. So think about solving a problem like that. Any solution that you're gonna propose have to be structured in a data-driven or at least evidence-driven manner, right? Wouldn't that be great if political discussion could be like that? Because I see that there's no root cause in political discussion, but that's another discussion. Okay? So here we just have that slide say, oh, don't jump to conclusions. That's what we call it. Jump to conclusions. Investigate things, right? And we have a natural tendency of jump to conclusion. You have to fight that. Okay? So what are we going to do? We're going to go from subjective to objective. I'm going to talk about this in the next video. This is too long.